Hello. How is everybody?
Hello.
I'm very excited to be here. And today, Jakob and I are going to be building cloud ready applications with Steeltoe and Spring. So don't worry, it's not going to be all Steeltoe. I'm happy that we've got a little bit of Steeltoe. Who are we? You probably know Jakob, but you might not know me. So my name's Layla, and I am a developer advocate, but for .NET. And that's what Steeltoe is. It's a .NET port of Spring Cloud Boot. So I'm going to be showing you some stuff today that if you're working on .NET applications and you want to bring all of your Spring stuff over to .NET, you can do that. I'm also a Microsoft MVP and a GitHub star, so I'm pretty entrenched in the .NET community. Now, my lovely co-host today is Jakob Pellerman, and over to you, Jakob, to tell everyone who you are.
Hello, good morning, good afternoon, or good evening, depending on where you are. I'm also a developer advocate. I mainly talk to our clients and consult our clients when it comes to domain-driven design, when it comes to their architecture, both logical and deployment architecture, when they need to refactor something and when they want to use Spring. But as Leila mentioned, Spring is not the only topic that we are going to cover today, because we'll have some demos in Steeltoe as well. Is that right, Leila?
It is indeedy.
All right.
So
The first question that comes to our mind when we see this title: what does cloud ready really mean? What is the meaning of cloud native? And I have a feeling that the more people we ask, the more answers we get. That's my understanding of that word. We, as IT industry, we love to come up with a term, and then we like to fight about this term. Is that still cloud native, or is it not? For the sake of this presentation, let's agree on a simple definition. A cloud-ready application is a legacy software program that has been somehow modified, whatever that means, to run on a cloud computing infrastructure, right? It might be that your cloud-native application is an application that was designed to reside in the cloud from the start, but you also maybe will need to migrate it somehow, which requires some modifications. I don't know if that's also your observation, Leila, but mostly cloud native involves cloud technologies like microservices, container orchestration, and auto-scaling, and things like that.
I mean, I don't think it's exclusively that, but I think that's generally where people's minds go when they hear the term. I guess where this leads us to, though, is why isn't my app ready? Why isn't it cloud ready? How can we put a pinpoint on when an app is cloud ready and when isn't it? And I think we can think about things more than just distributed systems as well, because some people will have smaller systems that are maybe just a couple of applications chit-chatting to each other. So I don't want people to feel like, oh, I don't do distributed architectures, so this isn't for me. That you can totally apply a lot of the things we're going to talk to your everyday application. So Jakob, why isn't it, more cloud ready? And, what is wrong? Why can't I just deploy my apps? Why can't I scale them just as I want? What's our definition for when it's not ready?
Yeah. So first and foremost, I would like to emphasize that cloud native is not an answer to everything. Like, it might be that your application is okay with whatever you are doing right now, but sometimes, especially currently nowadays, when our applications, when our systems, they have to react to rapid market changes, we have to adjust. And if we don't, then our organizations, they lose business opportunities. If that's the case, probably at least part of the system that we are working on might be or needed to be moved to cloud, because otherwise we'll have such problems. Like, it's hard to scale a specific chunk of your application if you have a huge monolithic application where everything talks to everything else. It might be hard to scale a specific chunk, like a specific business functionality that we want to scale. You will need to scale everything. And again, that might not be that problematic, but if it's problematic, the single chunk that you would like to scale probably needs to be moved somewhere else and reside in a cloud, probably. When it comes to maintenance, I have heard plenty of stories like this. Hey, we need to modify this specific business function, but if I want to modify this specific function, I need to modify this and this and this and that. And also, when I'm done, this is broken, that one is also broken, and so on and so forth. Because everything is not structured well, as the last style says in this on this slide. Application is not structured. We have tight coupling between different business components, which makes it also hard to release, which makes it hard to monitor. And when one of the chunks, when one of the functions actually breaks, we have, I don't know, a long garbage collection pause, or we have a failure in the database, or we just broke something, whatever that is. It might be that we have cascading failures in other places in our application, in our system. All right, that might be like a list of commonly seen problems when it comes to systems which are not cloud ready.
Cool. Okay, so we've bandied a few terms around, like microservices or distributed systems, and we can also talk about the modular monolith, which is my personal favorite. I'm a big fan of the modular monolith. But what does this mean for our developers who are actually working on these things? How do they come to approach this? What do they need to do with their architecture? You at home, what do you have to do to start moving your application? And we're going to call it a big ball of mud. Okay, I don't want to think that that's synonymous with the modular with a monolith, because monoliths can be beautifully architected, and you can have big balls of mud that are beautifully designed and have gone awry. But let's say that you've got this horrible application. It's a little bit tangled. We've got tight coupling. Everything's a little bit interwoven. It's a little bit like spaghetti. How do we get to that sort of microservices that we want when we start breaking bits off into satellites and we start individually scaling smaller applications and functionalities?
Yep. So I would like to emphasize on what you have just said. Monolith, they don't have to be bad, right? Per se. Like, it's not like in nature, when I have a monolithic application, I will have problems. No. I can have problems with microservices. I can have problems with monoliths. I have personally designed a microservice-based system years ago, which was causing many different problems. And I have also successfully designed modular monoliths, which were fine, even though I was one deployment unit. So I think we stole this slide from, I think, Simon Brown, but it's so cool that I can't do anything else when it comes to talking about distribution and modularization. We need that slide. That's the slide. We can ask at least two different questions about about the system we are working on. First question would be, is your system modularized? And by modularization, I don't mean we have separate deployment unit. I mean, do you have nicely shaped business-facing modules that actually represent whatever is happening in your domain space, in the problem you are trying to solve with the system you implement, right? That's modularization. If I don't have modularization, even though I have some modules, but they are like tightly coupled, and when I change one, I need to change all of the others as well. When I don't have that, I have so-called big ball of mud. If I don't distribute that, it means that all of the chunks that I have developed, they are very coupled to. They're very coupled, but I also deploy them as one deployment unit. I can make it worse. I can have my big ball of mud deployed as separate deployment units. I have done it. I've been there. It's like having all of the downsides of running a microservice-based application and architecture without having a single benefit. We might want to call it a distributed big ball of mud. It's even worse. It's the worst. I think there is not a single advantage of having this system, except for one maybe. I would like to learn how painful it is so that I'm not doing that anymore in the future. That might be the only advantage, actually, right? But then we can go to the right side of this diagram. I can have a modular monolith, still one deployment unit, but my modules are nicely shaped. When I have to change a specific business area, a specific business functionality, my changes in the code base, they actually are done maybe in one, maybe two modules, and that's it. It's easy to be changed. And then if I have modularization, and if I distribute some of the modules as separate deployment units, we might want to call it a microservice-based system. Most of us are in the big ball of mud area. That's by definition what's going on with the IT industry, because of the fact that we need to develop more and more and more and more features. We don't have time for proper design. That's my observation. Also, most of us, we want to be in the realm of microservices because it's cool and trendy. But at least from my experience, the modernization road, can't be done like you can see on this slide. So from big ball of mud directly into microservices, I've done it, and probably if you do it as well, you will end up in a distributed big ball of mud. So it's even worse. The road goes through this modular monolith. So I'm going to clean up my big ball of mud to notice that there are certain modules to be discovered and to be actually shaped in the current deployment unit, a single one. And then if I want to go further, I will maybe deploy some of those just distilled modules, new modules to a separate deployment unit, because I want independent scaling. I want independent release calendar, and so on and so forth. Right? Does it make sense, Leila?
I think so. I think this is a good process. I personally like to go to the modular monolith, just like you've suggested, and then I break off the modules into what I like to call satellites, and then that's the start of our distributed application. And I always think of our modular monolith like a Kit Kat bar, the chocolate bar, and each module is like a biscuit finger, and you can just snap it off at any time because you've designed it to be that loosely coupled. So let's say we have gone through this route, and now we have a lot of distributed applications. Okay, we've got our microservices. Now that could still have a modular monolith in the middle, and then our little satellites around it. I think we can go to the next slide now, Jakob. So how do they communicate? This is like such a fundamental thing. And this also applies within our modular monolith as well. How do we communicate between modules? And then how do we communicate to all of these different services in a meaningful way? And we're going to do that with messaging. So this is an asynchronous way. If you think about API requests through HTTP, gRPC, WebSockets, they're all what we would consider synchronous. They are something that you would want user-facing. Those are, you expect a response. It's that request-response pattern. Now, when we have a messaging system, it's asynchronous. We can fire and forget a message. And what that looks like is we have a producer on one end, and this is our application that is producing a message. And an application can be both a producer and a consumer. That doesn't matter, and you can have multiple consumers. So it will produce a message, and that gets on a queue, which is our message broker. And there's lots of different ways that can be implemented, and lots of different message brokers out there. But let's just say, most simplistically, that's a queue. We add a message to the queue, and then our consumer or consumers can come along in their own time. That's what makes it asynchronous, and get the message that is relevant to them when they want it. And then they dequeue it and do whatever they need to do with it. So this is a fantastic, highly scalable way of doing things. So definitely something that you'll need to know about. So Kuba, give us some other reasons why messaging.
Yeah, some of you were already mentioned some of the advantages. By the way, there is no free lunch. We'll go through downsides as well soon. But just to summarize, if I want to send a message to multiple consumers, or if I want to announce something and actually I don't care whoever is listening, messaging is the way to go. Otherwise, I would have to call all of those interested parties, and if one of them is down, or if one of them is down performing, it might affect somehow my internal business process, right? So broadcasting, sending information to all of the interested parties is easy. Multicasting, so just picking some of the interested parties is also easy. Sending to multiply consumers, it's easy, right? Temporal coupling, what's that? Temporal coupling means two applications, they have to be alive at the same time if they want to communicate with each other. Just like right now, if I want to talk to Leila, we both have to be alive at the same time if you want this communication to happen, right? Otherwise, it can't
I'd
be
like
done.
to be alive, thank you.
Otherwise, it can't be done. With messaging, we eliminate such an assumption, because if I die and then okay, this analogy doesn't make sense, but if I die
It's
and
very
then I'm alive,
morbid.
yeah, I'm alive again. In the so-called meantime, Leila might have left a message to the message broker, and then the message broker will see, okay, Jakub is alive. I will deliver that message, and she won't care, right? About the
No.
fact, right? Same applies to logical coupling. Logical coupling means I have to know there is a specific application interested in that specific fact or whatever I'm saying in my application. I will have to know, hey, there is a notification service. I need to call it. So there is some bit of knowledge that is required on my side. I am coupled to this second system, not only technically, but also logically. And I need to see this application in the network. So I need to be able to communicate with that. Hence the name spatial coupling. Messaging and message brokers eliminate that three types of coupling. But of course, it's not like it eliminates it all entirely, because I am still coupled as a producer of a message to the message broker, right? I need to know where is that. I need to be able to communicate with that, and also the consumer needs to be connected to the message broker. But if message broker is highly scalable, we can say that spatial coupling, logical coupling, temporal coupling is reduced between is eliminated between the consumer and the producer. And also, last but not least, we also have built-in throttling. As Leila mentioned, the consumer can consume the messages at its own pace, right? So these are the advantages, of course, as we said, right? No free lunches.
Oh, yes.
No free
So
lunches.
this does add a lot of complexity, but, Jakob, why don't you go through some more of these downsides?
Yeah. It might be more complicated to implement, even though with great tooling that we are going to see very soon, like Spring Cloud Stream and the equivalent in the Steeltoe world, right? They simplify the usage of messaging, but still, hey, I need to understand what's going on underneath as a developer, as an architect. And it's more complicated to implement than a single and simple request reply pattern, HTTP based, for instance, right? It's harder for me to see what was going on with a request, to follow that, to monitor that. I need some sort of tooling to monitor the communication path, right? Somehow with HTTP based communication, it's easy. I can see, hey, this service A calls service B calls service C, respectively, and so on and so forth. Which also makes it harder to debug when I have asynchronous communication implemented thanks to message brokers, right? I need to deal with the fact that the process is asynchronous. Whenever I deal with that, then it makes it harder for me to debug the application. We have all probably experienced that. And I have another piece of the infrastructure that I need to maintain somehow. Maybe I need to buy it. Maybe I need to provision that depending on my deployment preferences. But it's another moving piece that I have to have in the infrastructure, which wasn't present in the request reply pattern based on HTTP, right? Make sense still?
Definitely. So I think one of the things I'd like to highlight is that the implementation, you're going to do a demo for us in a moment on you, Jakob. So the implementation that we're going to see with Spring has more features than we do with Steeltoe. Now, at the moment with Steeltoe, we have Steeltoe messaging and we have Steeltoe streams. So that's just having a major update, which will be out in the next release, I think, which is in November, I believe. But we don't have multiple implementations of brokers. So in Steeltoe, we only have RabbitMQ at the moment. So, but that's not the case with Spring, is it?
Yeah, it's not the case with Spring, which I think makes it a great time to demonstrate
See a demo?
how it works. Yeah,
Let's
see a
go
demo.
for it.
All right. So first and foremost, I'm running a RabbitMQ container on my machine right now. As you can see, it was started 4 hours ago and still running. RabbitMQ on my machine. So this is the broker that we are going to use, and the tooling framework in Spring ecosystem that we are going to choose, because there are like multiple ways of doing that, is Spring Cloud Stream. Spring Cloud Stream makes it really easy to connect to Spring Boot-based applications via messaging. So what we will need to do is you need to specify, that's the producer application, by the way. We'll have the second one called consumer application. And in both of them, you will need to specify in your set of dependencies that you want to use Spring Cloud Stream, which which gives you streaming capabilities in your Spring Boot application, right? So that's this dependency. And also, you would need to specify to which type of broker, so what's the infrastructure that you would like to use and you would like to choose. Hence the second dependency, Spring Cloud Stream Binder Rabbit. As the name suggests, I want to connect to Rabbit. I can change it to Kafka or any other binder that is supported by Spring Cloud Stream. We support multiple binders, Kafka, Rabbit, AWS Kinesis. You can also implement your own binder if you don't like the ones that are provided by the maintainers. All right, so those two dependencies. Some people call them magical. I think these are the only sane conclusions that Spring Boot can draw out of those two dependencies, because it says like, hey, the author wants to stream messages, and he or she they want to stream to Rabbit. I'm going to connect to Rabbit, right? It's not magic. I think it's like pretty safe to assume that that's what I'm trying to do. All right. So now, when I start this application, Spring Cloud Stream will try to search for RabbitMQ instance running on a default port and default host, which is local host 90 something or 50 something. I don't remember the exact port on which Rabbit runs by default, but that's not important. What is important is that in the application properties, I have declared something like this: bindings. As you can see, I'm not talking about Rabbit, and I won't be talking about Rabbit in the application code itself. What I talk is that, hey, I want to bind to this specific channel. That's the name of the channel. That's the group ID, because also Spring Cloud Stream supports consumer groups that you might know from Kafka, for instance. And the destination is called events. So that means if the binder is set to Rabbit, that the application will search for RabbitMQ's exchange called events. If it's not there, it will create one. The same thing will happen on the other side. That's the consumer application. That's the POM XML with two dependencies that we already have seen, stream and stream binder Rabbit, and properties, binding. And in this case, I have called the channel, in this case, input channel, because I'm consuming application events coming from the broker. I have called it sync. All right, and the consumer group as well. But this one, the value of the property is the same. that's how both of the applications will be able to communicate with one single exchange on the RabbitMQ at the RabbitMQ's side. All right. So now let's write some code. That's the consumer application, and one way of consuming events is just to register a function, a consuming function. In Java world, a consuming function might be just a consumer, right? So if I register a bean like this, bean consumer, let's say we are going to send strings just to simplify this demo, and I will call it sync, and the name is actually important. Why? Because the name here matches this channel. That's why Spring Cloud Stream will know, hey, I'm going to bind this function as a handler for those events that are happening in here. All right, let me finish this. Consumer string. I will just maybe print it out. Why not? By the way, GitHub Copilot suggested that. That's a good hint. All right, so that's the consumer side. So now let's go back to the producer side. And again, I will register, in this case, a supplying function. In Java world, it's a supplier. So I will register something like this, supplier of strings, because again, we are sending strings, output, return, I don't know, something like whatever GitHub Copilot suggests. That's not very creative, but I will stick to that. All right, hello world. So I have a supplier function. Again, the name here is not by accident. It has to match the name of the channel to which I'm binding to. And both of them, by both I mean the producer and the consumer side, now will be able to connect to RabbitMQ Exchange. I will run the producer app right now, and hopefully in the logs we will see that, yeah, we have connected to RabbitMQ Exchange running on my localhost 5672. That was the port I was searching for in my head like 5 minutes ago. All right, and that's the producer app. So it's up and running. And let me run the
Kuba, just to
app.
interrupt.
Yeah, it's running, and you can see a periodic hello world. And now it might come to your mind, how come? Like, why we are sending those events, hello world, and what's the pace of that? So by default, and of course you can override it, and you can also send those messages on demand, which might be even a more typical use case, so to say. There is a registered puller which sends those events every second, if my memory serves me well. Again, you can override that. You can also send the events on demand, registering a different supplier. But more or less, this is how it works. The most important fact from this is that Spring Cloud Stream abstracts away the broker that you use in your infrastructure. So now, if I just were to change the POM XML to Kafka on both sides, it will try to connect to Kafka. Of course, there are some properties which are present in Kafka and are not present in RabbitMQ's configuration, or the other way around. But you can just specify them in your properties. Thanks to that, your code will be clean of the infrastructure concerns related to either Kafka or Rabbit or whatever binder you use. All right. That's enough. I think we can go straight to our next point. What do you think, Leila?
Yeah, I think one thing I wanted just to clarify. Am I on mute? I didn't.
All right.
Well, I'm hoping that everyone can hear me. What I wanted to clarify for folks while Jakub sorts his audio is that this is by convention. That these things are named that, but I believe that you can override those conventions. So the support and the consume, not the support, the supplier. Those names of those functions are by a convention. So hopefully Jakub is going to come back, because this will be a little bit difficult if he can't hear me. So we'll just bear with us, folks, while we try and sort this out. Let's
We are
see.
having some technical issues. I can't hear Leila. Sorry for that, but I hope our host will fix that very soon. Is that right? All right. I should rejoin, right? All right. Just refresh the browser. Okay. Okay.
Okay. So apparently, I don't think I can be heard either live. Oh, okay. Okay. So hopefully I can be heard live. So let me, I wasn't prepared to have the
All right.
slides up.
I'm back.
Oh, wait, Jakob is back, but let me get the slides just in case.
I still
And
can't hear Leila.
let's go. Okay. So just coming here to present. And we'll just whiz on through whilst we sort the sounds. And we're going to move on to service discovery. And this is kind of like a phone book for your applications. And it's going to allow us to have multiple instances of our application and be able to talk to them. So this is really important, especially when you have distributed systems. And the beauty of this is that it self-registers. So you don't have to do anything. And the least amount of work that you can do as a developer, the better. So let's have a look at what this actually looks like. If you think of, we have all of these backend instances. They're all the same application, just we've scaled up to 3 instances. We have our discovery clients sitting in front of them, and these instances will register with our discovery client. Now, when the actual client or another application comes across and says, oh, I'd really like to talk to this application, could you give me the IP address of where that instance or any instance that you want to give me actually is? So it will go to the discovery client, and the discovery client will return the address and location of that instance. And then the client can connect directly to that instance. So that is the theory behind it. It also does a lot of other cool things. So let's go on with a demo. So this one's going to be a Steeltoe demo. And what I'm going to show you now, if I can remember which way to go, I have, let's start in the here. I actually have an instance of Steeltoe Eureka running in here. And this, well, I should say it's Steeltoe, but it's actually a Spring app. So if I just stop this and restart it, you can see this is my Docker command that I'm running. So this is from the Steeltoe OSS library, and then this is a Eureka server. So if we run it, you're going to see a very familiar Spring logo with past. And then if I come back to here, and I come and show you what this looks like. If we go to the web UI, you see that there's nothing running here. We have no instances available. Let's change that. So in here, I have a .NET 6 project, and inside this solution, I have 2 projects. So I have a solution with 2 .NET 6 projects. Now, the first one is this dad joke API, and I'm going to stress that these are from the dad joke API. I am not responsible for any of the jokes you are about to see. So the only thing that I need to do is add the steeltoe.discovery.eureka NuGet package to my project. And I've done that in both projects. And then it's really just the matter of adding this one line to our IOC container, which is iServices. So we've added this into dependency injection, registered it, and Steeltoe takes care of the rest. We can give it some basic settings in our app settings. So if I come in here and we have a look, this is our Eureka client. Now this follows the exact same configuration as Spring. So this will be the same if you go to Spring. And we have our local host, and then we have these 2 values. And there's a whole host of other values, but these are 2 important ones that I wanted to show you. So we have should register with Eureka. So that's kind of like your app putting its address into the phone book. And then we have should fetch registry. That's your app getting a copy of that phone book. Okay, so in this case, I'm saying true. I want it to both register with Eureka and to consume Eureka. Okay, so to show this, what I want to do is run 2 instances of the Dad Joke API. So the first one I am going to do on port 5006. So let's get that going. And if I come back over to here, if I refresh here, you can see that there is an instance under Dad Joke API. That's the name of the project. I have Dad Joke API running on port 5006. Okay, so let's go and run another. So if I go to another tab, I'm going to actually run this one on 5005. So we'll run that. And that's going. If we come back here, refresh, we can see now I have the 2 instances. All right, good. So if I go and ask Eureka for the Dad Joke API, it's going to give me one of those locations, okay? So that's as easy as it is to register. Let's go and have a look at how we consume it. So this is my other project here, which is this one here. Now, as I mentioned, I have got the Steeltoe NuGet package for Eureka already installed. And just like before, in the program file, I go and register the discovery client with my IOC container. And what you'll notice here is I have the Eureka Fetch service, which is an hosted service. So let's go and have a quick look at that. And if we come in here, what we're doing is we're getting an instance of discovery client via dependency injection. So I inject that here into the constructor, and then I cast it as a discovery client. So we're injecting the interface, and I'm getting a concrete implementation. Oh, go away, everything. So then down here, I can use the built-in APIs in the discovery client to go and get all the registered apps. And then I loop over those and print some stuff to the screen. So let's go and run that and have a look. So in my third tab here, if I just .NET run this application, let's go. And I apologize in advance for the jokes. So straight up, you can see that the first instance is 5006, the second instance is 5005, and you can see here I'm hitting those different locations at random. So here we've got 5005, 5006, 5006, and it's just going to go and distribute through there. So there's a couple of ways that you can do your load balancing. You can let Eureka do your load balancing, or you can do it in your code yourself, which I think brings us nicely on to Jakob speaking about load balancing, if he is back. So I'm hoping that we can switch to Jakob's screen and continue.
All right. All right. Yeah, I'm back. To be fair, I was still here, but I couldn't hear you. Something has happened, so apologize for that. Fortunately, we are able to communicate. We are still coupled in time, right? You can hear me, I can hear you. All right, cool.
Hopefully.
Yeah. So let's talk about load balancing. Great question that you finished your part with. Who decides which instance gets called? So let's say I have 4 physical instances of the same one logical application or microservice, and which one I'm going to call, right? Which one I'm going to call when it comes to my load balancing algorithms. First and foremost, we can divide, and we can talk about 2 different ways of doing load balancing. One would be server side. And by server side, I mean you are not the one, by you, I mean the application that calls another application, to decide which application, which instance you are going to call. Server decides. Most typically, it requires to have another infrastructural piece that you deploy, like you can see on this diagram. Like it's there, you call this load balancer and it decides somehow. That's server side, right? Other way of doing that would be client side load balancing. Like for instance, I got an information from a service discovery like Eureka. Hey, if you want to call the dad joke API, these are 5 or 6 or 7 different places where you can hit if you want to hear some great dad jokes, right? You have 7 places. Which one you are going to choose? Me personally, as Eureka, I don't care. You will have to decide, and then you can have multiple different ways of doing that. For instance, you can do random rule. You can avoid a specific server because it used to downperform. If you gather some statistics, you can do round robin or whatever you like to do. All right. So these are 2 different ways of doing that. If you use, for instance, Eureka in Spring Cloud ecosystem, you can also add Ribbon. Ribbon is a client-side load balancer that you can use. You can use also load balancer abstraction on top of that to have certain algorithms. Of course, you can change the algorithms depending on the application that you call. So it's not like one per the entire system. Of course, you can modify that. All right, which brings us to another great topic, resiliency, because they have to be down-performing sometimes. And what's happening then, Leila?
So I think if we have resiliency, this comes throughout your whole application, but we're going to talk a little bit more specifically on HTTP clients and how they need to be resilient to failures. Now, we can do this with policies, and with Spring, you have various types of policies that we can use. With Steeltoe, we don't actually have anything to implement policies with, because we recommend that you use Poly and the Poly project, which is phenomenal. So why reinvent the wheel? So if you want to do any of the things we're going to show you in a moment, you definitely need to be using Poly for the .NET. So I think what is resiliency? We have retries and fallbacks, and the kind of thing that we really have is a circuit breaker. So just to quickly go through what a circuit breaker is, it's from an electrical circuit. If you think about it being closed, that's always good. So we want it to be closed, and we can set a failure threshold limit. But when that's exceeded, the circuit opens, just like your circuit at home. Okay. And then what happens? We wait. And then when that starts to, we give some time to the application, and then it goes half open, which means you can send one request. And then if that's successful, it's closed again. If it's not, it goes to the open stage. So that is a circuit breaker. Now, we don't have time to show you a demo, but Jakob, did you want to just elaborate on how you do that in Spring? Just like, is there any more nuance to it?
We don't have time for like nuances, but if you are interested in that, please take a look at, for instance, resilience4j. I will show you a dependency that I'm talking about right now. We had the demo ready, but we don't have time for that. So if you include, for instance, resilience4j, which is one of the implementations of a circuit breaker pattern, another one would be like Spring Retry. There's also a deprecated version of circuit breaker called Hystrix, used to be maintained by Netflix. Anyways, that's the way to go. And then the API is pretty much easy to follow, because you wrap whatever you don't trust. By don't trust, I mean it's downperforming, it fails every now and then in a circuit breaker, and it opens, closes, or goes to the half open state automatically, and you don't have to do much work. So that's when it comes to circuit breaker pattern. That's all. Which brings us to monitoring. Do we have time for that? Yes, we have 2 minutes, right?
We have some minutes. Okay, so with monitoring, it is really, really super straightforward to add. I mean, in Steeltoe, it's a matter of adding a NuGet package and then one line of code. And I believe it's really similar in Spring, is it not, Jakob?
Yeah. By the way, I will have a next presentation today in like 3 hours with my dear friend Nate Shuta. We are going to demonstrate this and circuit breaker as well. because of the technical issues we had today, we weren't able. But again, as Leila mentioned, the thing you are looking for when it comes to monitoring is Spring Actuator. I never know how to pronounce that word, so sorry in advance. Spring Actuator.
It was correct.
Thank you. Cool. So Spring Actuator is the thing to search for when it comes to monitoring, right? We don't have time for demo, but what we do have time for is deploying to TAP. Do you want to elaborate on that, Leila?
Sure. I think TAP is designed to work really well with Spring, and it just allows you to automate your build pipeline and continuously build and release, which means that you're going to be faster and more efficient. We know that you want to continuously release and keep going, and TAP is a really great tool for that. Now, I want to say that for Steeltoe, it's slightly behind Spring on TAP, and Steeltoe and .NET applications are still more optimized on TAS, which is the successor to Cloud Foundry, if you remember Cloud Foundry from Pivotal. But I will say that .NET and Steeltoe is fast catching up Spring for on TAP. So you'll learn there's a whole third track for everything TAP and platform related. So if you want to hear more about that, you can head over there. And we didn't cover, like, we would need hours to cover everything that we wanted to do. So you definitely need to think about security, 12 factors, testing, scalability, distributed tracing, API gateways, so many different things, which you will learn about in other sessions today. Okay, so have a look around at what sessions, see what interests you for what you want to learn. But I guess that's a big thank you from both Jakob and I. Yeah, I think that, thank you for bearing with us through our little technical audio issues there. Jakob, do you want to add anything else?
Yeah, thank you as well. And if you would like to read more about anything that we covered today and anything that was supposed to be covered but we didn't finish, please go to one of those links, depending on if you're interested in Java or .NET, Spring Cloud, or Steeltoe. The documentation is amazing. Like, I have never worked with a project which is so nicely and developer friendly described as Spring and Spring Cloud and Spring Boot. I can't say the same about Steeltoe because I have never read the documentation, but Leila will probably say something more about this. Everything that you need is there with hundreds of tutorials. That's probably one of the most, that's the project when it comes to documentation. That's the reference project. I cannot stress it enough. So big thank you for everyone that maintain documentation and the code base as well. All right, with that, I think we'll have to finish because we are 3 minutes past the time. 2 minutes, not that bad to be fair. Thank you.
Thank you.